Me a favor, my friends. We're going to talk about welders. And as we talk about welders, Article 630, guys, talk about welders, special equipment. And for welders, I'm going to do the following. I'm going to take a group of welders, and we're going to size the service for them, as you can see of the sheet that you have, number one. And number two, we're going to take a branch circuit. So could you please go to Article 630? That's okay. You can go check on it. Tell Gary if it's working or not. Okay. If you guys go to Article 630, please. No? Okay. Article 630. For Article 630, guys, we're going to talk about two types of welders as we move through. Arc welder. So if you do me a favor, highlight the first thing I would like you to highlight in this article as right highlighter, text highlight. I would like, is it okay? Did you tell Gary? Yeah, thank you. I would like you guys to highlight arc welders first. So that's what we're going to be doing. We're going to have an arc welders, and we're going to size the service for an arc welding shop as well as the branch circuit. So could you please go and highlight arc welder first? I would like you to highlight the ambiguity of supply conductors. That's how we're going to be connecting them. I would like you to highlight individual welders, A, and in particular for individual welders, guys, I would like you to highlight the rated amps, multiplied by the rated amps. So shall not be less than the current value determined by multiplying by the rated amps. Supply conductor shall not be less than the current value determined by multiplying the rated amps given on the welder rating plate by the following factors. Okay, here's what I want. If you guys do me a favor too and highlight this table talks about multiple welders. If you have multiple welders, a group of welders, that's how we're going to be sizing a group of welders based on this table. So you're going to see in this table, guys, a couple of things. You're going to see the cycle, as well as if it's non-motor generator and motor generator welder. So does it have a generator or doesn't have a generator in it? You have to know that beforehand. And I would like you guys to highlight way at the bottom. It says this particular section here. It says the sum of the 100% of the two largest plus 85% of the third largest plus 70% of the fourth largest plus 60% of the remainder welder. 60% of the remainder welder. This is going to make a lot of sense as we go through, guys. So for the time being, if you guys do me a single favor and highlight this. All right, so let's go. So we're going to be here. I'll be jumping in and out in a second here as we move through. Let's go turn our, okay. All right, so here's the example that you guys all have. I have welders, and they're all arc welders. The article that's going to be talking about the arc welders, as you guys can see in the 630.11a and b. And the example that we have, Ashley, my friend, is I have 6 welders coming from the same feeder, and each one of them have different cycle. It's going to run a different cycle, and the full load amps of each one of them is given, as well as if it's non-motor and motor. Everybody can understand what I wrote here? We have 6 welders. Each one of them has a motor, is identified as a motor or non-motor, and the full load amp is given for each one of these welders. Any question, guys, about the given? Any question about the given? So I have welder number 1 through 6. The cycles are given. I have a shop, 6 welders. Each one of them has different cycle. Just for the example, the full load amp on the nameplate of it is given. These are all given, and also given if it's non-generator type or generator, non-generator, non or generator type.
determines the
motor generator or non-motor generator?
determines the cycle percentage?
The way it's on him, the way you use these welders. So it will be on the side, on the welder itself will tell you what the cycle is. Is it 90, 80, 30? It's the way they use it. Yes, determined. Not us. Not us. You're absolutely right. All this information that you're looking at, the blue information, guys, is determined by the manufacturer. Everything. Any question about this? So what's my goal? My goal, my friends, is, if you look at the second page, here's my goal. I have a service panel right here and feeding all these six welders from one panel. And my goal is to size the service conductor coming to this panel, as well as the overcam protection device, the main bonding jumper, and the grounding conductor. Exactly what we did yesterday. Exactly what we did yesterday. William Jackson, question?
No.
So what we're going to do, guys, as you can see, is we have a service coming in here. I have my service coming in here to the service conductor coming to a panel, and I need to size number one, as you can see, is the panel. Number two is the overcam protection device. Number three is the conductors coming in. Number four is the grounding electrode conductor, and number five is the main bonding jumper. Exactly like we did yesterday. Exactly like we did yesterday. What's the difference is? Different type of load. Cool? Everybody knows what the outcome is. Why am I doing what I'm doing here? To size a service panel for a shop that's full of welders. Cool? Everybody has this diagram in front of you, so it's not a biggie. Okay, so that's, and I'm going to be walking you guys. You have the sheet in front of you. It gives you all the way up to the main bonding jumper. So that's all the way up to the main bonding jumper. When we size, Ashley and Tom, my friend, we always start with the loads. Your start point when you size anything is a load. You have to know what type of loads inside your building. So the load is given. Okay, so let's go ahead and find the following, guys. We need to do the calculation based on 630.11a and 630.11b. The first welder is full load amp is 50. The cycle is 1, and so the calculation. Let me use what color are you guys using here? Green? Are we using green this area for you? No. Just match what. I don't think you do. Okay, never mind. So I'm going to use it green. So the first thing, you start with welder number 1. The full load amp of welder number 1 is 50. You're going to multiply welder number 1, the first multiplier, guys, and then by the second from the table, the first multiplier is going to be 1. The second multiplier is going to be for the cycle, since the cycle is also 1 and it's non-motor, the derating factor from the table is 1. So the answer here should be 50 amps. Any question where the first one came to be and where the second one? What's the first one mean? What does the first one mean? The second one means the cycle. If you guys go to table, let's go directly to here. Okay, the first if you guys look at this, the first motor that we have is, the cycle is 100. Can you guys see the 100 cycle here? Let me undo and let me undo here. Okay, I have 100 cycle. Can you guys see the 100? And it's my motor is non-motor generator. What's the factor from this table? The derating factor from this table. The derating factor from this table. And everybody can see the 1. This is where the first one, the second one came to be, right? So what you do, guys, is you take the full load amp and you multiply by the cycle. The more 100% cycle, you don't derate at all. If it's less than 100%, you start derating the amps because it's not going to be fully engaged at the same time. Yes, sir.
You have like non-motor,
the first one is motor. You're absolutely right. So let's go and highlight. It's the same answer, but you're absolutely right. Let's do it the right way here. Edit. So I'm using a motor here, and my multiplier is 1. Any question as where this one came to be for the cycle? The second one, there are two ones. The second one, guys, it says group welder. Minimum conductor ampacity shall be based on the individual current determined by 630.11a as the sum of the 100% of the two largest. Can you guys see where the second one came to be? 100% of the two largest. So the first two largest, we're going to take them at 100%. Okay. So let's go back and let's go back to my. So where's the two largest, Chris? 40 and 50 amp are the two largest. So they say the first, the number one is 100%, another 40 times 100% multiplied by, what's the cycle for the 40? What's the cycle for the 40 amp, guys? 90, right? Can you see that the cycle is 90? So I'm going to go, if the cycle is 90, let's go find the cycle 90. I have a 90 cycle. Can you guys see that what's if the cycle is 90, what would the derating be? 0.96. Everybody knows where the 0.96 came to be then? 0.96. So then I'm going to go to 0.96. So let's go back. Everybody knows where the 0.96 came to be. Good. So the second is going to be, so this is 1, this is this is my point. Okay, there you go. 0.96. And if you do the math on this one, I already did the math for you, my friends. It's 38 amps. 38 amps. Any question, guys, where the first one came and where's the 0.96 came to be? Yes, sir.
Yeah,
The first what?
the number one.
Good point. Let me highlight these two. I'm going to highlight this and this, right? Everybody knows where the second one and the 0.96 came to be because of the cycle. Where does the 1 came to be? Right? Right? That's what you're asking for? Okay, these are coming from, very good point. These are coming from right in here. Do you see this here? Let's go. It says the two largest, you multiply them by 100%. Does that make sense? Can you guys see that? The two largest are multiplied by 100%. The two largest are multiplied by 100%. As long as we're on it, Rob, my friend, plus, I want you the 80%, can you guys see the 80% of the third largest, 70% of the fourth largest, and 60% of the remaining welders. Can you guys highlight these? The first two welders, 100%. Then the remainder, the second, the third at 85, the fourth at 70. Don't ask me why. And everything else after that at 60%. Make sense? This has nothing to do with the cycle. That has to do with grouping them in one, grouping the conductor, grouping the welders together. When you group them, there's a diversity factor, guys. This has to do with the diversity factor, the grouping. They are highly unlikely they're going to be engaged at the same time. They say, okay, take the first two largest 100%. We're going to assume they're going to be running. Everything else start derate.
But it was important that you listed them in order.
Yes. And I made this intentional.
Yeah.
To make them in order so you start.
Then you, yeah.
Okay? Now, everybody, so this is where the one came to be, the first one, guys. Then the second one, as you know, right here and right here. Okay? For the cycle. They're not going to be engaged. 100% cycle, it's welding more. Less cycles, less welding. Less current consumed. Any question, guys, about this? it makes a lot of sense when we start doing it in a second here. Okay, so let's go ahead and go back to mine. Okay, so this is where the one came to be. Let's go to the third one. What does the third one say? The third one is also a motor generator, and it's 30. So let's go do 30 multiplied by the cycle. For the cycle, guys, it said the third one is said 0.85, 0.85, and for the cycle is 0.91, 0.91. If you do your math, you're going to end up with a 23 amps. Okay? Now, Jackson, my friend, where does the 0.8 came to be? 0.8 came to be? 0.85 came to be? Can you guys see where the 0.85 came to be? From right in here. 0.85. Where does the 0.9 came to be? What was the cycle of that one again? The cycle was 80. So here's an 80 cycle. And it's motor. So everybody knows where the 0.9 came to be? 0.91. 0.91. Any question, guys? Any question? Any question about that? Okay, so let's continue. Let's go back again. So Oladipo, now we're done with the motor ones. We're going to go to the rest. The rest of them are non-motor generator ones. And I have a 20 amps. For this one, I have a 20 amps multiplied by. Okay, now the third one is 0.78. No, the third one is going to be 0.6. This is a 0.6. And next, do you know why this is a 0.6? Because the first two at 100%, the fourth at 0.8, the third, right? The fourth at 85. Anything else after that one is 0.7. So this should be 0.7. Thank you. This should be 0.7. 0.7. Multiplied by 0.7. Multiplied by, what's the rating factor for 70 cycle? How would you know the 70? It's a cycle 70. Here's 70 cycle. It's now we're dealing with non-motor. The cycle 70 gives you what? 0.84. Any question, guys, about that? 0.84. Chris, does it make sense?
Yeah. Do you have time to explain what it is you're talking about as far as welders?
Like the cycles?
They seem to be talking about resistance welders, non-motor generator, motor generator.
This is the way they make welders, as far as I understand.
So it's like a nameplate thing.
On the nameplate, you're going to have an arc welder. It says arc welder. Right underneath it, you're going to have motor generator with all this information.
Okay, so the device itself will say this stuff.
All this information will be said on the device. What's the difference and which one will better? I really have no clue, and
No, I just like to have a subject before.
Yeah. So, but you see, my point is, these are all the nameplate. I look at the nameplate. If it's within this criteria, that's how I size it. Which one is better? How do they work? And all this is a whole different arena. Any question, guys? For 70, the rating factor is 0.84, right? Any question, guys, about so this will be times 0.84, and if you do the math on that one, you're gonna get 12 amps. Any question, guys, about this? 12 amps. Any question? Any question? Okay, let's go to the third one. The welder number 10. Welder number 10. what is the group percentage for welder number 10? 0.6. What's the group percentage for welder number 1? 0.6, because anything after the fourth start 0.6. Right, Chris? 0.6. All right. Now, multiplied by, what is the cycle derating factor for, I want to remind you, it's 60 cycles, 10 amps at non-motor generator. What's that value? Okay, let's go to the, if you forgot, here's 60. So we're going to go all the way to 60. My factor is 0.78. 0.78. Any question, guys, about this? Any question? 0.78. Okay, so this is where this came to be. 0.78. And if you did the math on this one, you're going to find the 5 amps. You're going to find the 5 amps. The last one, do you guys agree with me that the last one is 5 times what is the group percentage? This one, these circled one, group percentage. 0.6. All of them, after that, it's all 0.6. Multiply this one by what is the cycle derating factor. The cycle they call it multiplication factor for the arc welder. The multiplication factor. For 50 cycle, I'm going to go back to the table. It's a 50 is right here. And my factor for a non-motor is 0.71. Right? Does that make sense? 0.71. No problem, Chad. 0.71. 0.71. And that will get you a healthy 2 amps. Unreal, huh? Healthy 2 amps. Any question, guys, about this? Any question? Yes, no? Any question? Make sense? Does not make sense? No? Yes? Okay, so we grouped all these 6 welders in a panel. Now we're going to go size the panel. We're grouping them in a panel. We're going to go size the panel. Any question before I leave this? So there are 2 factors, Rob. Factor number 1 is the group. Let's go back. They call it the duty cycle multiplication factor, right in here. And factor number 2 is the group factor. Does that make sense? 2 factors. The first factor, we multiply the group factor, which is basically the first 2 at 100%. The first 2, the third one at 85, the fourth one at 70, everything else at 60. And then you go by the cycle. What does the cycle means and how does it work and all this stuff? Care less. I look at the nameplate. If this is the cycle, if this is the motor generator, if this is the amp, the rated amp on the nameplate, that's how I size it. Any? The voltage? In a second here. Just give me 1 second. Any question, guys, about using this table first? Any question about using this table? Question about using this table? Okay, so then, okay, so we're going to go add them all up. So, Nick, my friend, when you add them all up, right, because they all fit from the same feeder, when you guys add them all up, you're going to end up with 130 amps. So do they add to 130 amps? Do they add to the 130 amps? Okay. So when you add them all up, why do we add them all up? Because they're all fit from the same feeder. There's 6 of them. Add the amps up. So we add them up. You end up with 130 amps. 130 amps. Any question, guys, about this? Piece of cake. It's really the learning curve. How, my friend, is how to go to the table and do the derating for these. Now, let me ask you this, my friends. If I, William, my friend, if I add another 100 welders here, would it change the topic? Would it change how we size it? It just makes things more tedious work. Really wouldn't. The only thing, always ask yourself, Chad, tell me what the cycle. Is it an arc welder? I need to know, is it an arc welder? Yes. What's the cycle? What's the full load amp from the nameplate? And is it non-motor or motor generator? If I know this information, then this is how you do the calculation. Add them up. Any question, guys? Any question? Makes sense, William? Okay. So moving. Okay, now the rest is, you guys are very familiar with it. Now we're going to go size the panel. Now I assume, here's the assumption here. Here's the assumption. And the assumption is I have a service panel that's feeding only the welders. So I'm sure Jackson sitting there said, Chad, what happened to the light in that welding shop? Ignore everything. By the way, if there's light, what would we do? If I have another 20 amps worth of light, what do you do to the amps here? Just add them up. Really not a whole lot of info. Okay, so this is the service that we're having is 28123 phase. You asked about the service. We're having a 28123 phase service. 28123 phase service for these welders. They're all rated for 283 phase, 3-phase welders. If they were single-phase welders, you do the same calculation for single-phase welders. You really go by the amps. By the way, they all have to be either 3-phase or single-phase. Otherwise, if they're all 3-phase welders, 208. So for all practical reasons, that on 30 amp, this could be 240-120 single-phase. The panel will be single-phase then. The welders that we bought, all of them are 3-phase 28120. Okay, cool. That has to be given. Okay, the next is piece of cake. You take the 100, then you take 130 amp, guys, that we calculated. Take it to D Walt under 312, right, Chris? 312. And what's the size of the panel gut that you need to size? 150. 150 amp. Now we're going to go size it for 150. Any question, guys? So I'm going to go call Color Hammer and ask them for a 28123 phase 150 amp panel. Okay. The second one is the overcome protection device. I do it the same way, guys. The overcome protection device for the feeder. Can you guys see where the number one is the guts, number two is the feeder? Everybody can see that? So for the feeder, piece of cake, Chad, you take the same 130 amps that you calculated. This time you need to take it to 240.6, and that will get you, what's the next standard, Chris? Is it?
If we go up, it's 150.
You go up 150. And you go up to 150 amp. So we basically hit the jackpot. 150. The panel matches, my panel matches the overcome protection device, and that's the best scenario that you have as a designer. When your panel and overcome protection device match, meaning you don't have copper inside the panel that's not used, right? You're taking full advantage of the copper.
There's some place where it's going to go up rather than down.
You can go down at any time. Your equipment will be undersized. In this case, it really doesn't. No, it doesn't tell you.
They tell you you made the block.
You what?
Is there any place where they tell you can use the next size up?
No, no. To accommodate, because we're using panel to accommodate for all the equipments, and as what you can add in the future, we go up. Okay, the last thing is feeder. The last thing is a feeder. This could be, in this case, could you please erase this one? Instead of a feeder, I'm going to call them service entrance conductors. I'm going to size the service entrance conductors. I said match overcome protection device. Now, code-wise, guys, code-wise, you can really go and size based on the 130 amp. But Good design is always match the overcome protection device when it comes to panel. Always match the overcome protection device when it comes to panel. So healthy wise, so you're going to go to the table, NEC code, and you're going to go to table 10, here you go, all the way and size yourself a conductor. Let's go all the way and do it one time. Okay, so I have 150, so I'm going to go to the 75-degree column, right? Because I defaulted to 75 after 100. So I need 150, my 150 amp panel, my 150 amp. Can you guys see that right in here? 150. It takes how many watts? 1 watt. It takes 1 watt. It takes 1 watt. Let's deviate from this. Undo. It takes 1 watt. Okay, cool. So we're going to 1 watt. Everybody knows how to use the table, so we're good. 1 watt, and we're going to go all the way and size this conductor. So match it. I want to say take here you go. Take 150 amp. Take it to 310.15 B16 under 75-degree column. And how many conductors do I need? Now, I need at least 3 conductors. Do I want to bring neutral to this panel? It's a good idea to bring neutral to this panel. Can I derate the neutral? Am I higher than 200 amp to derate the neutral? I'm not even close to 200 amp. I can't derate the neutral. So I'm going to use 4 conductors, including a full neutral. 4 conductors. Each one of them is 1 watt, number 1 watt, and they're going to be THHW. Done. I have 4 conductors, number 1 watt, THHW. Which conduit? PVC schedule 80, if it's service, is a good suggestion. And what's the conduit size that you're gonna be doing it? What's the conduit size for these? If I remember how to use that one. Chris, what do you come up with? Schedule 80.
Schedule 80.
2. Schedule 80.
These have 20% expansion.
Schedule 80. I have how many conductors? I have 1 watt, 0 wire size. How many conductors do I have? 4. THH, I don't have THHW up here. And conduit size, 2 inch. Did you say 2 inch?
Yeah.
Yep, came up 2 inch. So, what I would like to do, guys, always is to put 2 inch PVC schedule 80 right at the top. That's what the feeder is. A feeder is nothing if you don't specify the conduit that these conductors are going to be housed on, right? So why PVC schedule 80? Good idea if you're doing 3-phase service underground, most likely. You're coming from underground. So put a 2 inch PVC schedule 80, 4 conductors, 1 watt. Either you use your calculator or you can do it from, in this case, Annex C. Any questions guys about this?
Yesterday we were using 40, today we're using 80. Is there some decision-making process?
I thought we did 40 for the 80 for the service yesterday. It really judgment. If
At
it's
what point would you just make the decision on the
physical damage?
Pardon?
Physical damage.
Is the 80 thicker?
Yeah, physical damage. That's it. Can I use, for example, let me tell you what I can use for you, no question asked. I'm coming from underground transformer, underground all the way into the guts of a switch gear, right into the switch gear. Nothing exposed to any physical damage. That schedule 80 will do it. Schedule 40, schedule 80. I'm coming from a transformer to the side of Dunwoody building here, go up against the wall into an elbow and get into the building. So that somebody could drive his car right into that conduit. Physical damage, schedule 80. I like to default schedule 80 for 2 reasons. Number 1, I'm the engineer and I don't pay for it. That's not a good argument, right? Number two is if you're Schedule 80, you don't go wrong under any circumstances. But value engineering, Ashley, you walk in and say, well, Schedule 80 is going to be expensive. We know there's no physical damage. I want to go Schedule 40. No problem. But if you as an engineer put on your conduit Schedule 80, you as a contractor, you have to provide Schedule 80. It's not non-negotiable. So you guys are the ones who work at Michal and everywhere else. It's going to be your shot. We put schedule. We as an engineer, we go higher than the code. For one reason, because we don't pay for the material. Okay. Any question, guys, about this? Any question about the welders? Any question about the welders?
So,
Go ahead.
okay. I see.
So we size the panel, we size the overcap protection device for it, and we size the conductors plus the conduit. Piece of cake, right?
Strictly a welder.
Yeah. When we say, Chad, what happened to the receptacle? But here's what could happen then. Suppose that this welder shop has to be some lights. Suppose it also has some receptacles. So what do? Remember what we did yesterday? You take the lights for the welders and take the volt amp for all the lights, multiply it by 1.25. All the receptacles in that welder, that's convenient receptacle, multiply them by 180. Derate them if they're more than 10K. Add them all up. And at the end, you're going to add them, change them into amps based on the voltage and add them to this number. Because you can't add apple to oranges, right? So when you say you came up with a light and receptacle, okay. Look, I only have one Chris now. I don't have another Chris here. Okay, but you know what I mean. You have to convert them. 130 amp three-phase, guys, is completely different than 130 amp single-phase. Completely different. Everybody knows that. If I have this is 130 amp three-phase 208, it's completely different than 130 amp 208 single-phase. Completely different. So you have to add them. To add them up, we have to either convert to kVA or convert to amps. Any question, guys, about this? Okay, let's go find the second one. Grounding electrode conductor. We did that yesterday. Grounding electrode conductor. Phil, my friend, we size it based on 1/0, and the table you're going to go to 250.66. So take this one to table 250.66, and that will get you a healthy one conductor. And number 6, A, W, and G. Could be copper, it could be bare, insulated, or covered. That's it. That's the grounding electrode conductor. Everybody knows what the grounding electrode conductor is. Everybody knows where this baby is located. That's the one that's going from here down to the ground rod, or to the water, or to the steel of the building. Okay. The last one, guys, is main bonding jumper. Can you guys see where the main bonding jumper? So, William, my friend, you have your neutral and ground right at the service. You are by code in the US. Other parts, they don't do it, by the way. You have to take the neutral and bond the neutral to the ground. You stabilize the neutral by bonding it to the ground.
Did you come up with number 6 for our EGC?
Yeah. 250.66, number 6, yeah. So the main bonding, yes, sir.
What is that, number 10? Or 250.66?
Number 1.
It looks like it's 10.
It is a 10, but now it's going to be one out. Thank you. Number 1 out. Oops, that's too big of an out. Okay. All right, 1 out. Any question, guys? The last thing is the main bonding jumper. Main bonding jumper. Main bonding jumper That's when you bond a neutral to the ground. This is you go to 250.28, and it refers you to 250.66. So please write these 250.28, refer you to 250.6, and oh, by the way, you take the number 1 and out, you take it to table 250.66, and that will get you a healthy 1 conductor and number 6 A, W, and G. Any question, guys? Any question?
In general, they appear to be the same if you're looking at the same, that's the point.
But
The-
when it gets larger,
Yes, when you hit the 1100 kcm, they become different. If you hit, if this number, Chris,
Okay, on that,
yeah,
that 28 column.
yep, the 28 will tell you if you go more than 1100 kcm copper or 1700 kcm aluminum, then the calculation, these two are the same, up to a conductor of 1100 kcm. After that, they start diverging. They start diverging. Any question, guys? You want 5 minutes break, or shall we keep going? 5? Let's take a 5.
So basically, we get smaller once the wire reaches a certain size.
Okay, so I have a welder of the resistant type. So let's go back to my code, and I want you please to highlight a few things, and then you see. Let's go back to here. No, not to here. Minimize this, go all the way to Mr. Welder. Now, okay, so we know this is an arc welder. The second type of welder is resistive welder, guys. For the resistance welder, please highlight this section. You guys are with me with the NEC code book? Just go highlight section 3, resistant welding. In particular, I want you to highlight the following. This table. So you have the rated amps of that welder. Then you have to adjust the rated amps of the welder based on the cycle of the welder. There is no generator in this one, motor generator. So you're going to highlight this table. And also I want you, for group installation, I want you to highlight the following. The ambiguity of the conductor that supply 2 or more shall write in here. If you read this, it will tell you if you have a feeder that feeds multiple welders of this type, you take the largest, fattest, fluffiest welder at face value, plus the rest of them you cut them by 60% because of the group influence, the group derating. Does that make sense? This is all what you need for resistance welder. So Ashley, my friend, if you have a welder with 5% or less cycle, you have to derate the amp of this welder by 0.22, because that welder is not going to have a big impact on the grid, on the panel. Okay, any question, guys, about this? Knowing this, let me go highlight it. Knowing it, so grab it. All right. And so we have, oops, wow. So they went fast. That went fast, huh? Let me see if it can take me back. No? Where am I here? Took me a long way away from where I want to be. Okay, let's go back to my friends, the welders. And let me see if I can get my, okay, wow. Okay, doesn't want to do it. Okay, let's go back into my welder and go back right in here. Okay, let's go back to the presentation, my friends, of N right here. Okay, so here's my welders. These are nameplate values given first for you. I have welder resistance. We know where 630.31 A and B are. We've just went to the table 630.31 A2. Was it A2? Yep, A2. Now we're gonna go apply it. Okay, so the first one I have a 50 amp. This is the fattest and the fluffiest. Nick, we said the first one, if it's a group installation, you allow it at 100%. Just the first one. So you multiply by 1. Then, based on the cycle 50, what would the multiplier be based on the cycle 50? Anybody can tell me? 0.71. Thank you. It's going to be a 0.71 equal. Done. So that's based on the cycle. It's going to be 0.71, and that will give me at 36 amps. Any question, guys, where the 1 came to be? This one came to be because the first fattest, fluffiest, largest motor, you use a 1 for it. The remainder at 60%. Okay, let's do the second one. The second one is 40 multiplied by 0.6. Anybody knows where 0.6 came to be? From the table, 0.6 multiplied by, for a 40 cycle, if you guys look for 40 cycles, it's 0.63. 0.63, and that will get you a healthy 15 amps. 15 amps. Any question, guys, about the 1 and the 0.6? The 1 and the 0.6?
Yeah, the presumption on the cycle is if it's over 50%, you just drop down to 50.
If it's over 50, you're going to use 50. If it's... That's a good point. What if it was 60?
Something's wrong. No.
What if it was 60? What if it was 70? This will indicate to me, guys, that it seems they don't make them more than 50. Yeah, they don't make them more than 50. Any question about this? Let's do the third one. The third one is 30 amps multiplied by the same thing, 0.6, because anything after the largest, fattest, fluffiest motor, it's 0.6. You multiply this by 0.55, Aldibo, right? 0.55. That will give me 10 amps. The second one is 20, multiplied again by 0.6, multiplied by, for a 25 cycle is 0.5. 0.5, and that will give me 6 amps. And the last one, the one before the last, 10 amps, multiply this one by 0.6 again, multiply this one by the cycle. The cycle for 20 cycle is 0.45, and that will get you a healthy 3 amps. Talk about nothing. And then 5 amps multiplied by the same 0.6, because 0.6 go for everything except the largest, fattest, and the multiplier is 0.22, and that will get you a healthy 1 amp. Any question, guys? Straightforward. Straightforward. Any question? Any question, my friends? Okay, so what do you think we do after that? We derated them. We're going to add them up. We're going to add them up. We're going to add them up.
I think there's a mistake. I think you're supposed to. Oh, no. Forget about it.
Did we do anything wrong? Everybody knows how to use the table, right? Can I have a okay thumbs up? Everybody knows how to use the table, right? Okay. All right, so add them up. Now we're going to add them up. When you add them up, equal, all these will equal what? 71, I have a 71 M. 71 M. 74? Anybody came up with a different? 71? Okay. You second me. 71. Did you get come up with 74, please?
71, yeah.
71.
We think so, it's rounded.
Okay. Then the next is piece of cake. Now this voltage, I'm burning him at Chris. Look at these. I decided to use 482.77 for these welders. I don't know if they make them 482.77. You really go by what the welders are rated for. I'm sure they make 482.77 welders or 480. Okay, so take this. Then you take the 71. Now we're going to go size the panel. Exactly what we did for the rest of them, guys. We're going to go size my panel, piece of cake. You're going to take the 71 amp, take it to D wall 3-12, 3-12, and what's the size, the minimum size? 125 amp. 3-phase, right? Everybody look at 3-phase panel in D wall, right? 125. Okay, piece of cake. Then overcome protection device, 71 amps. I would take this one to 240.6. And my next overcome protection device is 80 amps. My next overcome protection device is 80 amps. Right? From 240.6. Now feeder, I want to change this word feeder, guys, into service because I'm dealing with the service here. Service, conductors. Match overcome protection device based on CAD, CAD. So what's my overcome protection device? 80 amps. I want to take it to 310.15 B16. Now, when we go there, now, Chris, it's an 80 amps, less than 100. So I default to 60. But, unless you know otherwise, you default to 60. Unless you know otherwise, you really default to 60. So I don't know anything about this equipment. I'm going to default to 60. And what's the size? I have 4 conductors, number 3 AWG, right? Now, if your conductors are rated, if this equipment is rated for 75, guys, then I can go to the 75. I can get away with a smaller conductor under 7580, number 4. So I can go from number 3 to number 4, one number. Most likely, this equipment is actually rated for 75, and most likely going to be number 4. But unless I tell you otherwise, you go by the amps. Any question, guys? Any question? Okay. Can we move to the last 2 pieces of that? So the last is the grounding electrode conductor. This is, as we all know, my friends, it's going to be 250.66 stable mostly. I have number 3. You take this one to table 250.66. It gives you a healthy number. Number 8. One conductor, number 8. I'll change this one in a second for you guys. Number 8, strictly based on the table. Number 8. And the same thing if you go take number 3, take it to the same table, 250.66. You're going to get one conductor, number 8. One conductor, number 8. This is this one from 250.66 table and 250.28. Okay, the challenge with number 6, guys, if your grounding electrode conductor is less than number 6, you have to provide physical protection. You have to put in a conduit. So, moving forward, so you met the code. Engineering-wise, practical-wise, I wouldn't go for less than number what? Number 6. So I would use number 6 for both of them. The minimum that you should use in a panel is number 6. But really, strictly speaking, the table can allow you to use number 8. But number 6, less than number 8, you have to provide physical protection for it, put in a conduit. If it's EMP on both sides of the conduit, then you get into a whole lot of issues. So, get into the habit, no matter what your conductor is, grounding electrode conductor and main bonding jumper, your minimum is number 6. Okay, cool? Can I get you guys to see the value of number 6 here? Any question, guys? We're looking at a main panel here. Any questions? Any questions? So we cover 2 types of welders. Arc welders, resistive welders. If you guys know these 2 examples, you're done for any type of welder. We didn't size the conduit. Let's do the conduit, Chris. The conduit is number 3. Conduit type, PVC. I need 3 conductors. The wire is number 3. And I have 4 conductors, THH And what is the conduit size? I have 2.5. Chris, what did you come up with?
3, 4 of them. 1 1/4.
So you are 3 copper, 4 THW conduit, 1 1/4. I think I didn't clean my so this is what's the conduit? THW is the conductor, and this is going to be 1.25 inch PVC schedule 80. You're expected, guys, as a designers, as an electrician, when you size a conductor, you can't put a conductor up in the air. You're supposed to find a conduit that holds the conductor, right? So 1.25 PVC schedule 80. The last thing I want to cover about welders are the branch circuit. Now these are the feeders and the service. Had this been a feeder or a service, oh, by the way, Rob, if that cable number 3 here was a feeder, would the calculation change? No, nothing will change in this calculation if that was a service panel or a feeder, right? Everybody knows the difference between a feeder and a service entrance conductor. The first conductor comes to the building, land on the panel, it becomes a service panel. This is assuming a service panel. Now, if this wasn't a service panel, it was a sub panel somewhere downstream, an equipment panel, nothing will change. The only thing will change is 2 things. There is no main bonding jumper, it disappears, and the grounding electrode conductor becomes equipment grounding conductor, and it's sized from a different table. It's sized from a different table. It's sized from a different table. It's the only difference. The calculation continues to be the same. Okay, now, excuse me. Now, I want to take a branch circuit for arc welder, a branch circuit. Now, what we have done is a service and a feeder. I want to do calculation for a branch circuit. Just one little tiny branch circuit. Okay, for one feeder. One little tiny branch circuit. You guys will do the rest. I'm going to do overcome protection device as well as a conductor side, branch circuit conductor for a feeder. Now, Tell my friend, I want to remind you, this is the panel that we have just sized, and I picked only one load because they're all the same, one load, and I brought a circuit breaker with a feeder to tie to this load, right? Typical circuit breaker to a feeder. And my job and yours as electricians and engineers and designers is to find the conduit and the conductor that feed this welder. Find the conduit and the conductor, size them, that feed this welder, so you can give it to yourself or somebody else to go install it. Okay, it's a little bit tricky here. When you do an overcaptation device for a welder, it's a little bit tricky, and I need you guys to bear a little bit with Chad, to bear a little bit with me. So if you look at the branch circuit, we're going back to the arc welder. The branch circuit for arc welder. Okay, so we're gonna go. The first thing I want to assume here, we're gonna do some assumptions. We're gonna assume that we have terminals. Let's assume one thing: the terminals are rated for 75. So we're gonna do a 75 terminal. Otherwise, we're gonna go to 60. We're gonna assume everything. Most likely, if they're welders, three-phase guys, they're 75 rated terminals. Okay. So let's go ahead and size the branch circuit for this baby. Okay. I started with the overcam detection device because it's very important. I started with the overcam detection device because it's tricky. Not with the conductor, for a reason. So if you guys go to overcam detection device, it says go to 630.12a. If you look at 630.12a, it will tell you you can size it. You can size the overcam detection device for the feeder and the welder based on 200% times the rated amps of the welder. Rated amps of the welder. So this is, I need to highlight this one. Very interesting. So right here, if you guys go with your friend Chad, welders, overcam detection device, right in here. Okay, for welders, overcam detection device for welders. Can you guys see that one here? Overcam detection device for welders, either A or B. Okay, so where the rating was sitting result in unnecessary opening of the next higher standard. I want to highlight this one here. The next higher standard only can be used if it keeps opening. Right here. The next higher standard only if it keeps opening, you use it. Only. So let's go to this. For welders. I'm going to highlight for welders here. At 200, can you guys see 200%? 200% here of the rated load amps. Okay. And also I want to, so you take 200% multiplied by the rated load amps, no derating. Can you guys see that? And I want to highlight this one too. For conductors, it says if the supply conductor for welders are protected by an overcam detection device rated or set at not more than 200%, then of the rated amps of the welder, then a separate overcam detection device is not required. I want you guys to look at these. This is tricky. You either have two circuit breakers. If you listen to me, you either have two circuit breakers, one to protect the welder right at the welder, and the other one in the panel to protect the feeder. Two circuit breakers. One by the welder to protect the welder, and one by the circuit breaker. Either you do this or you do it the easy way. The easy way is to have one circuit breaker inside the panel to protect the cables as well as the welder. To do that, if you guys look at it, both of them need 200%. To do one circuit breaker, you're going to do it the way I'm going to do it right now. Okay? In a second. So to do one circuit breaker in the panel to protect the welder as well as the cable feeding the welder, you're going to do it the way we're going to do it in a second here. Okay. So I'm going to highlight, that's why I highlighted these. Let's go back to the presentation. and right in here. Okay, so overcome protection device. Take this. If you look at what we just said, guys, I'm going to say it says 200%, which is 2 multiplied by the rated load amps. What's the rated load amps of this big fat boy? 40. No derating. No derating. 40. And then that'll get you 80 amps. If it's not a standard, if this is not a standard, you're supposed to go down unless it doesn't hold. So you're supposed to go down unless it doesn't hold, then you can go up. So the assumption is you go down. Okay? So here's an 80 amps. So this, hold your horses, this could be, I'm not saying should be, it could be 80 amps. And I don't know about you guys, but if I take 80 amps to 240.6, that will give me also 80 amps. And if it's not standard, what do you need to do? Go down. If it's not a standard, you're going to go down. Okay, so hold your horses. We're not done. This is okay to a point. This is okay to a point. Now let's go size. This is how the overcome protection device is going to be sized so far. All right, that's easy. 2 times 40. And Chris, I didn't modify the 40 at all. I didn't modify it at all. Okay. If you guys go to Brent circuit, any question about the overcome protection device? Straightforward. 2 times the rated load amps from the welder, and go to the standard. If it's not a standard, go down. Unless when you went down, it keeps tripping, then you can go up. But the default is go down. Okay, the Brent circuit. For the Brent circuit, first, here's what they do for the Brent circuit. Take the 40 amps, multiply it by the cycle multiplier for the 40 amp. The cycle for the 40 amp is 90, guys. Motor generator. So motor generator 90, it's 0.96, right? That's the multiplier from the table. You have to multiply it by point. What did they say? Was the cycle 40 or 90 for that one? Okay. So what's the multiplier for? So the cycle is, let's use it for 90. The cycle is 90% motor generator. So what's the multiplier for 90? 0.96 for motor generator. That was a motor generator, right? Or was it non-motor generator, the first one? Motor generator. So if it's motor generator, so it's 0.96. Just going to try to match it what we have here at the beginning. The first one was motor generator. Yeah, motor generator, the first one. Good. We're good. So 90, then the multiplier would be like Chris said, 0.96. 0.96. Can you guys give me the answer for this, please? 35 amps. 35 amps. Okay? So you take the amps and derate or modify the amps based on the cycle. And that will give me 35 amps. Cool. 38. Chris, did you say 38?
That's what I get.
Oladipo. What's going on at Oladipo? 38. 38 amps. Cool. 38 amps.
38.
Oladipo, don't make me upset now and start crying here. 40 times 0.96.
Multiplied by 0.9. 0.96.
0.96. This is the cycle. You have to look up the. This is just to get you the cycle. You go to the table from the 0.9. You get the cycle for 0.9 is 0.96. The multiplier is from the table. I'm giving you the cycle. This is cycle. This is the cycle. Cool? All deep, does this make sense? Cycle. Okay, 38 amps. I don't know about you, Chris, but I have my 30 amp. I'm going to take it to 310.15 B16 under Let's assume, guys, it's typical equipment, 60-degree column, unless I know otherwise. What's the conductor under 60-degree column that can carry this amount? I need help with this. Number 8? Can number 8 carry it? Number 8? Okay. So I have number, how many conductors? I need to have 3 conductors, just 3 phase. 3 conductors, number 8, A, W, G, T, H, H, and N. Okay. Number 8. Number 8. Any question, guys, about this? Number 8 conductor. Number 8. Here's where the check that you have to do, guys. Number 8. Number 8. Pretend that. Okay. All right. So let's go back. Everybody got the number 8? So we're number 8. All right. Here's the situation that I have. I have an overcome protection device tied to an equipment, 40 amps. This is 80 amps. Did we say 80 amps? This conductor is number 8 conductor. This is a welder. If you are to only have one circuit breaker here in the panel, this is inside the panel. If you have to only have one circuit breaker inside the panel, guys, and no other circuit breaker right in this area, no other circuit breaker right in this area here, right? So you either, in order to have one circuit breaker right here and no other circuit breakers right next to the equipment, in order to do that, you have to do this check. You have to do this check. Did you guys hear me? In order to make this work, you have to do this check. The check is, you take the number 8 and go to 310.15B16 under the 60-degree column. How much current that number 8 can carry? 40 amps. You take the 40 amps and multiply it by 2. And what would that give you? 80 amps. In order to do it this way, you cannot protect this conductor for more than twice what's it rated, what is it rated for. Does that make sense? In this case, we hit the jackpot here and we end up equal. But let me tell you what could happen. Suppose that you end up with 60 here, 60 amps. Suppose that you end up here with 60 amps. In this case, we end up with the same. Suppose we end up with 60 amps here, then I have 2 options. Either you grab the 80 amps and put it right here, and it becomes like this. This is an 80 amps, and this is 60 amps. That's one solution. 60 amps in the panel to protect the cable, and 80 amps to protect for the equipment, right? Or you have to go for the next standard up conductor, which would be number 6, right? Which most of the time would go number 6. Does that make sense? This is for the welder, no?
Well, just that if you have a 40 amp, a 60 amp breaker, the 80 amp will never get a chance to break.
Yes. So, but in order for the same breaker to protect the cable and the welder, you cannot exceed this value here.
So what's the 80 amp circuit breaker doing?
It's just for the welder, protecting the welder. If that makes sense.
It can never break. It makes no sense.
Yeah, because the one, well, that's why you have to up your conductors. That's why then you go back to 60, 80 again, no problem. And what do you do with this? You make it 60, number 6. Okay. Does that, so get into the habit always, guys, of sizing the conductor you find the amps, and make sure the overcome protection device amps is not more than twice the amps of the conductor. If it is, then get a higher conductor. Get a higher conductor. So long story short, without missing the whole thing here, in my example, you come over here. This is my 80 amps. I have an 80 amps, no problem, good to go. So we're good at 80 amps. Because it's twice as much as what the conductor is rated for, not more than twice. So we're good. If you don't believe me, you're going to go to the NEC code book. And you're going to look at exactly this one. Press right here. Why can't I? Right here. See what that one here? Everybody can see that? If the supply conductor for a welder are protected by an overcap protection device rated or set at not more than 200%, then of the rated blah blah blah, a separate overcap protection device shall not be required. A separate overcap protection device shall not be required. So a smart design is always check. You need only one circuit breaker right in the panel to protect the cable and the equipment. So just do this check at the end. And if it's not, then up the conductor. That's the best way to do it. Up the conductor. Okay?
I just can't see any circumstance for putting a larger conductor, a larger over current protection device.
You're going to up the conductor. You just want to up the conductor. Defeats the purpose because it's... Okay. Any question guys about this? So we have... The last thing I want to size is the equipment grounding conductor. The last thing, yes, sir.
Is there any circumstance where you would put one on either end?
I can't think of one. I can't think of one.
Is that
Yes.
panel there just feeding the welder?
No, there will be other. Yeah. Oh yeah, there will be other things here. I'm just showing one welder. Yep. There will be. This is a complete panel. There will be other things here. It's like this panel here.
But you may not have other devices on that particular circuit.
Yes, this is a branch circuit. This particular baby is number 8, 3-conductor number 8 branch circuit. That's it. Branch circuit means straight to the equipment, stops.
Okay, so no taps or anything else.
Not in this case.
Not in this case, but can I tab? Yes.
Okay, you have-
It changes the calculation though if you start tabbing. Yep. This case is one load per circuit. Yes, Rob?
Where we got that 80 circuit welder, would be, could you use like time breakers for solid 80 right away?
You know what? I don't want to go there, but you can make it happen if you do coordination. You can, yes, you can. But my humble judgment, the best design is one circuit breaker in the panel, and if the conductor is smaller, then just up the conductor. But yes, you can play. What you're saying is, here's the trip curve of one circuit breaker. I can have another trip curve of the same circuit breaker that's completely different. Yeah, you can play with the settings. The settings of the trip curves of the circuit breaker. I don't want to go there though. Not this time. Okay, shall we design? Does it make sense? Yes, you can tweak it down to make it work. Make one trip before the other one short circuit, especially on short circuit. Yep. Equipment grounding conductor. This is, guys, equipment grounding conductor. This is from table 250.122. Okay? And this is always sized based on the 80 amps. You're going to go to table 250.122. If you guys go to table 250.122, what would you get? What would you get? 250.122? What size conductor? Number 8? Number 8. One conductor, number 8. AWG. This is the equipment grounding conductor. Here's the ground. This is this one. Number 8. Now we happen to be the same size as the phase conductors. That's okay. Here's my question for you. What if this calculation here end up with number 6? and the phase conductor are number 8. Do I have to put number 6 equivalent grounding conductor? No. So no matter what this calculation here come up with, if it comes up with more than number 8 in this case, number 8 is the largest. This apply for all equipment grounding conductors, guys. The equipment grounding conductor does not need to be more than the phase conductors. Doesn't need to be. Any question, my friends? Any question? Any question? So we got, let's do the same thing for resistive welder, and then we're done. Resistive welder. The same application for my branch circuit sizing for an arc welder. We're going to do it for resistive welder. Was it 40 amps? Yeah, resistive welder. Now the same application, guys. I want to take you so you don't argue with your friend Chad. The overcome protection device 460.32 A and B, especially B. We're going to size the following. The same calculation. You're going to have 2. Let's use a different color here. You're going to have 2 times the full load amp of the resistance welder, the 40. This happens to be 40. That will get me 80 amps. 80 amps. No problem. That's good to go, Chad. And then you take the 80 amps to 240.6. That will give me 80 amps. If it's not a standard, what do? You go down. Exactly like the arc welder. Exactly like the arc welder, you go down. Exactly like the arc welder. Cool. Any questions, guys, about this? Questions? Arc welder. The density of the conductor and it's really, it's 32, it's a different code section, but it's really repeat what we've done. Okay, so this one, we multiplied by 2, and I'm going to tell you why I multiplied by 2, because of the conductor size. The same principle for conductor size, guys. Now let's look at the conductor, though. The conductor is an issue. For conductors, look, Chris, what we're going to do for the conductor. Take the 40, multiply by the multiplier from the welder side for 40 cycle. My cycle is 40 here. My cycle is 40, right? This is cycle. My cycle is 40. What's multiplier for 40 cycle from the resistance welding? 0.63. Thank you. 0.63. That will give me what? If you do the math on that baby, what do you get? 25 amps. Thank you, sir. 25 amps. Okay, no problem. 25 amps. Now let's do the same sizing. We're going to go 25 amps. Take this one to 310.15 B16 under 60-degree column, because I don't know better for these welders. We're sizing them under 60-degree column. If you know the termination is 75, you size based on 75. What do you get, Chris? Number 10?
Yes.
You get number 10? Everybody gets number 10? So I get 3 conductors, number 10. A, W, G, T, H, H, N. Okay? 3 conductors, number 10, A, W, G, T, H, H, N. T, H, H, N. Now, this is where you're going to do the check that we just talked about, guys. Any question about this? We're almost done. Any question about this? Yes, sir.
Is there a reason why we use 3 conductors?
3 phase.
We get neutral?
No. Most likely you're not going to need a neutral, no, a three-phase welder. If you need, you add a fourth conductor. Good point. Okay, now before we go, guys, I'm going to take you to the same example that we've just did. Here's my panel, and here's my overcurrent protection device coming all over. This is one of them. To my 40 amp welder. Now this is resistance welder, R welder, and this was, first what was it, 80 amps? This conductor was number 10. Now, the same rule apply. If you are to use the same conductor, can you see that? If you are to use the same overcurrent protection device here, then this conductor cannot be protected more than twice of its ampacity. Let's go check. So here's number 10. Chris, how much current can number 10 carry? 310.15 B16. 60-degree column. 30 amp. Okay, Chris, take the 30 amp and multiply it by 2. What do you get? Now we're in trouble. You've got a 60 amp. The maximum that you can protect this conductor based on these circumstances is 60 amp fuse or circuit breaker. Do I have a 60 amp? Now I have an option to make. Either change this baby right here, change this one into 60 amps and bring another 80 amps here, or up my conductor to the next size. 99% of the time you're going to up your conductor to the next size. So this is the best. The best is to do, okay, so I'm at 10. What's my next standard? 8. Let's go check 8 though. AWG. It's not enough. Take the 8 to 2. Oops. Take the 8 to 310.15 B16 under 60-degree column because I said so. And what would that give you? 40 amps. Let's check. I have a 40 amp. Multiply the 40 amp by 2. What would that give you? 80 amps. Have we hit the jackpot? Yes. So then this conductor must be now changed into what? Number 8. 3 conductors, number 8. This conductor must be changed to 3 conductors, number 8. Unless you want to put a number 80 amps here and a 60 amp to protect the conductor, not a good idea. Does that make sense? So always size based on the conductor, basically.
So put a larger one from far end and make it instant trip, then it would have some effect.
We're here.
Correct.
You don't want to go there. You just size up your conductor. Yes, William?
I was going to say, if you
You were saying.
put something in there, would you have to up the size though?
If you put one here?
Yeah, you'd have to have the number.
No. If you lower this to 60 and put the 80 amps here, then you don't have to up the conductor size. But here's what you're taking, the chance that you're taking though. You're taking a chance every time you start your welder, the 60 amp will trip. Because ultimately they're in series. Yes, they're far away from each other, so there will be some buffer between them, but ultimately they're seeing the same amps coming into the circuit. That's why I hate to say that option of putting it, there's a solution with adjusting the circuit breaker, but really the best scenario is one circuit breaker up to handle the inrush and up the cable so it can't be burned because of overloading or so. Any question, guys, about the welders? Any question about the welders? Now, the last thing is equipment grounding conductor, Chris. So I'm going to take number. So now we know I'm going to take you guys back here. And remember that all this stuff that we did, I want to put a cross over it and say this will be number 8. And everybody knows why we moved to number 8, right? Why we moved to number 8, based on the check that we did. So go back. All right. So the equipment grounding conductor, William, my friend, I have table 250.122. You size it based on the overcurrent protection device long time pickup, which is in my case, it's 80 amps. We stuck with the 80 amps. take it to 250.122. What's the size? We just sized it a minute ago. What was the size? Number 8. Number 8, AWG. Number 8. Any question, guys? Make sense? No? Any question? This will wrap the welding calculation, guys, with 2 good examples. Tomorrow after those guys leave, I want to take one more calculation about recreational vehicles. Do calculation for recreational vehicles and arenas, both arenas and both yards. We'll do a calculation for this. Any question about this before we move on? Any question? So may I ask if everybody now, guys, know how to size a panel for a welding shop and a branch circuit for every welder based on the 2 types of welders that we have, right? Now, Chris, if I take you back to this, my friend, and say now, go back to my welding example right here, and I say, Chris, I have 6 branch circuits here. Can you size the branch circuit for the 40 amp? Bring it on. Same calculation. Branch circuit for 30 amp. Yep. 20, 10, 5. All these branch circuits, easy to size them, right? Exactly like we did the branch circuit. The feeder, we already sized the feeder. We already sized the feeder. Okay. Branch circuit, we did the branch circuit for them. The last thing I want to mention, guys, before I let you go for lunch, what happens if you have other loads in the same panel? What happens if you have other loads in the same panel, right? What happens if you have other loads in the same panel? And you need to size the panel. So I'm going to take the first example that we did, guys, and just add 2 loads to it, just 2 loads. So if you do me a favor, go back to, let's do the, which one is there? The arc welder. Let's do the resistance welder, example number 2, resistance welder. I want to remind you, Chris, that we are, well, just to make it, because I don't want to mess with, well, it might be a good example, 41, because the amps will be different here, because the voltage is different. Let me just go to a first example that we've done. Okay, the first example was 28120, right? 28120, perfect example. So I want to remind you guys, in this example, we came up with 130 amps, okay? That's a load. Now I want to go grab a chunk of light and throw it to the same panel. Chunk of light and receptacles. That's what I want to do. All right? So I'm going to remind you, there's 130 amps here, and we came up with 50 amp panel. So take this one all the way to here. So now I have my panel. Here's my panel. I don't know what the size is, but I know one thing. I have multiple welders coming out of this panel. 1, 2, 3, 4, 5, 6. And these are all the welders, and we did the calculation for them. These are welders. And that was, what was the amp again? 150. And not the panel, the full load amp, 130. I have 130 amps for these welders. It's already calculated, right? 130 amps. Now I decided to throw a bunch of lights, lighting circuits and receptacle circuits. So look what I'm going to do. I have a bunch of lighting circuits, and these are just, I'm going to call them here. These are branch circuits of lights, and I have demand. Everything is demanded. I applied 125% of everything, right? Demanded. I added a 10 kVA load here, 10 kVA load. After I demanded it, I increased it by 125% and everything else. This is for light. Then, to add salt to injury, I added receptacle, another, let's say 5 kVA receptacle. It's already demanded. So I applied the first 10,000, which is anyway, there's no 10,000 here. So it's everything here demand. No, I don't need to demand it. I don't need to multiply by 1.25 because that chunk is multiplied by 1.25. I don't need to demand this. Okay, everything is demanded, just to make it easier. Now we're gonna go size the panel. We're going to size the panel. Very easy. I want to remind you guys, there's 130 amp here. Here's what you need to do. This is coming from example number. Let's make example number 1 addition. Number 1. I add addition. I added to it. This is so easy, guys, that you're going to laugh when we're done. You're going to take, add them up. So you take the two together. I have total added. The total added to the panel was what? 10 plus 5 equals 15 kVA, right? I added 15 kVA. I just add them up. I can't, our depot, I can't add 15 kVA to 130 amps because these are apples and oranges and they don't match. That's where we said we can't add. Can I add 115 to 130? It becomes 145 watt amp or volt amp. So I need to convert this one into amps. Piece of cake. Where did it go? It wasn't piece of cake. Okay. Extend view. No, please bring me my view. Okay. Might have to do that one by hand. All right, there you go. We came back. So I need to find the amps. Let's go find the amps. I equal for the added 15K. Now, Chris, do you agree with me? You agree with me that the voltage system is 208/120 volt, 3-phase. So I need to multiply this, divide by 1.73 times 208 to find the amps. Can somebody help me? Take the 15K, find the amps for the 15K. Why did I divide it by 208/120? Even though the light and the receptacle are single phase, because they will be divided between the 3 phases. They will be seen as a 3-phase load, even though actually they are single phase line to neutral load. But when you divide it between phase A, phase B, phase C, and neutral, they will be seen amp-wise as a 3-phase load. Chris, what's the answer? Anybody can help me, William? 42 amps even. Second, 42 amps. 42 amps. Done. Now we're going to go, what do you think I'm going to do with the 42 amps now? Add them up. So I'm going to go next. Take the next step. I'm going to take the 130 amp plus 42 amps. That will get me 172 amps. Now we start doing the sizing. And I'm going to do it quick because you guys are good now with the sizing. I just want to make sure that I'm using the same numbers that we used before, so nobody can yell at me. We used, which color am I going to be using? I'm going to use, choose black. This one is number 1. This is number 2. This is number 3. Oops, number 3. And Ford McGrath conductor. Let's do that one. So here's my ground, here's my neutral. This ground to neutral bonding, and this grounding electrode conductor. These are typical, guys. This, I call this one number 4. This is 4, and this is 5. I want to go find these 5 things exactly like we did, guys. Exactly like we did. The only thing now, we threw 42 amps at the panel, which is more practical. We have receptacle and lights in the panel, right? More practical. Cool? Everybody can see what we added? The 1 through 5. All right, take this. I'm going to do it right quick, guys, because you know the. So I'm going to go number one. Number one was my my panel size. So I take 172. Chris, take this one to D Walt 3-12. What's the next standard? 225, 3-phase. 172. Is there a three-phase though? Are we looking at 200? Okay, 200 M. Why am I confused with that one? 200. So I thought the next standard for 225, but it could be, should be, would be.
Three-phase four-wire system.
Yep.
200.
Three-phase four-wire system, 200. You are right on the money, man. 200. Okay, 200 there. Piece of cake. Number 2. Overcurrent protection device. This is 240.6. Take the 172. Chris, now do what's the next standard? I think this is 275. 175. 175. Yeah, they should be in DWALT too, right in the same page in 13. 175. I believe there's 175. Yep, there is right in the center of 3-13, 175. 172, you go next to 175. Okay. Why it's important, guys, to size the load based on overcurrent protection device? Then you don't have to pull 200 amp cables. You can if you want to. Okay. The last, the third, what was 3? The cables, the feeders, conductors. Conductors, as in service. Service conductors, right? The last one was service conductor 3. I'm going to go size. I'm going to say here match overcurrent protection device. So I have 175. I need somebody to help me here. 310.15 B16 under 75-degree column. 4 conductors. I'm going to pull full neutral. How much? 4 aught. 2 aught. Thank you. Number 2 aught. AWG THHW, and Chris is going to work on the conduit for us. Any question, guys? See how the panel went up from 150 to 200 amp panel with 175 amp circuit breaker. PVC schedule 80, Chris? Okay. See if you came up with the same I came up with. All right. Any question, guys? I'm going to do 2 more things: the grounding electrode conductor, which is piece of cake, and the main bonding jumper. Number 4, grounding electrode conductor. This is 250.66 table, and it was number 2 aught based on my friend 250.66. Chris, what would that, not Chris, Nick, what would that give you? 2 aught, 250.66. What's the size, guys? Or anybody else? What's the size? Anybody? From number 4? How many? 1 conductor, number 4, AWG, cover, bare, insulated, or covered. Number 5, main bonding jumper, 250.28. It refers you to table 250.66 if you guys go there, and that will give me the same calculation. 2 aught, take it to 250.66. That will get you 1 conductor, number 4, A, W, and G. Bare, everything is copper. bare, covered, or insulated. Doesn't matter. Any question guys about this? That's it. Any panel. When you comes to any panel, guys, you have to size the panel, the overcompression device, the feeder is coming to the panel, the main bonding jumper, and the equipment and the grounding electrode conductor, if it's a service panel. Chris, what was the size of the conduit? I'm sorry. I came up with 2.5.
2 inches, 91% full.
I wonder why.
Uh,
This calculator came up with, what is it, 2 out, right? 0, 0, clear, 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 0, 0.
2.5.
What is size?
A lot more room, but 2 will fit. I mean, this.
4 conductors, THHW. Did you use THHW?
Yeah.
And conduit size. 2. No, 2, you're right. I think you're right. So the conduit here, guys, I always like to put the conduit. You're not a designer if you don't size the conduit with everything. So 1 conduit, 2-inch PVC schedule 80. Why schedule 80? Because we're assuming physical protection. Service is a good assumption. Service is a good idea to do that. Any question, guys? See how we did the calculation for the welder, first with all the welders only. Now if there's receptacles a light piece of cake, just add them as amps, throw them at the end. Make sure you add the amps at the right voltage. At the amps at the right voltage. If this panel gets, this is an interesting one, and I will let you go. I promise this time. I want you guys. 208. 208. Okay. Where am I here? You can leave though. If you want to go eat and you're hungry, you can leave. All right, so where are we here? Okay, this is a 208. Oh. All right. Now we're going the wrong way, Chad. Okay, this is a 208, and also this one goes the 208. 208. Now, Phil, my friend, if this was 480 amps, can I add a 130 480 amps to a 42 208 amps? No. So what would you do? You have to convert them with the voltage ratio. You have to use the voltage ratio to convert them. That's why I picked this example, because the receptacles and the lights and everything else was burning at 208, 120. It's easy to compare them. But had these welders been 130, 480, and this load is coming from 208, I have to do the conversion where you take the 208 divided by 480 and then multiply it by this number. So it lower it because it will be seen as lower amps at higher voltage. So, or easier, or
Transformer this thing?
or
Three different
yeah.
voltages.
Yeah, you can do a transformer, no problem. Or easier, the easier if the amps guys if these amps were 480, if this panel was 480, it's easier actually to start right here by dividing by 1.73 divided by 480. So we'll give you the receptacle amps at the 480 level. Okay. So we're not there. So that's what I have. Any question, guys? Anybody has any question? All right. How to do it? Use a calculator to use a wire size? Okay, let's do that one-on-one. Let's everybody go eat. Okay, thank you, guys.